As my project is Women Safeguard, and now let's start this project with. Firstly, we will start from the introduction. As we know, in the today's world, women's safety is a critical concern, and despite advanced technology in our society, many of the women still feel unsafe when they are on the work or traveling alone. So, to address this issue, we are here to present the Women Safeguard, a compact wearable safety device using a Raspberry Pi that can act an effective tool for ensuring women's security. This device aims to provide real-time monitoring, instant alerting, and location tracking in emergency situations. Now, what is our problem domain or problem statement? The increasing rate of harassment and safety concerns for women call for an efficient, portable, and accessible safety device. Traditional safety devices like paper spray or alarms have limitations in their terms of reach, effectiveness, and practicality. So there is a need to change little bit to a smarter device that can not only alert trusted contacts but also provide a real-time location. So there we are using a lot of different sensors or tools for ensuring that problem to be solved. Currently, some of the industries are practicing on this with the various movement safety devices like applications available such as panic button, wearable devices like smartwatches and mobile applications that send alert messages to the user or the trusted contacts. These solutions are either respective triggered by the user after sensing danger or on manual actions, limiting their effectiveness in the highly critical situations where immediate actions is required. And they are facing some challenges like manual activations, limiting coverage, and lack of real-time monitoring, and battery life and size. Firstly, if we discuss about the manual activation, the most systems require manual interventions, which may not always be possible in emergencies. And secondly, limited coverage. Many devices really rely solely on smartphones. Connectivity require the user to remain within the proximity of their phones. And then if we talk about the battery in the lives of the so many portable devices are struggling with their battery balance and the battery life and size and functionality. Now, if we come to the gap and opportunities, automation and continuous monitoring, there is an opportunity for a system that can monitor potential dangers like sudden factors or environmental factors and automatically trigger the alarm or alert without user intervention. It means like user should not be always required to touch or provide the alert with or herself. It can automatically detect by the sensor and trigger a message and send the live location of the user. An embedded system, a Raspberry Pi based embedded system could integrate a multiple sensors and communication protocols to enhance the real-life safety monitoring responses. That means using the Raspberry Pi, we can attach a lot of various different sensors for using this device as a very portable and effective for the women safety. So we can attach a lot of different tools with the Raspberry Pi to make sure that it will become a good device for the safety in the terms of embedded system and compact and powerful, leveraging Raspberry Pi's capabilities for an affordable, compact and versatile solution. Now here we are proposing our solution. The project proposes the development of the compact women safety devices using a Raspberry Pi sensors. Some of the sensors like GPS, accelerometer and the pulse sensors. The communication modules. For the communication modules, we are using the GPS, Wi-Fi or Bluetooth. Wi-Fi for setting up the Wi-Fi setup so it can provide the trigger the message on the user's mobile phone. The system would automatically detect emergency situations, example or abnormal heart rate and sudden movements through the environmental factor or indicating a fall or struggle, and sends in real-time location with the data along the alert to the emergency contacts that the user already had saved in. So the main components and the interconnections for our project is like we firstly require the Raspberry Pi, which will be the central processing unit for the system. Secondly, we will use the GPS module that will help in the detecting the real-time location data. Thirdly, we will use the gyroscope sensor or accelerometer for detecting the sudden movements or abnormal parameters of the indicative of the danger. And then we are using the heart rate sensor for continuously monitoring the user's heart rate. If the heart rate is abnormal, it will detect the it will detect by our sensor and will trigger a message to the user's emergency contacts. And then we will use the GSMR or GPRS module. It will send an SMS alert to the emergency contact with a real-time location. Then we will use camera, which will be optional for recording the video and audio of that intent, and for a good evidence. Then we will add a battery, which will provide the power to the whole circuit of our safety device. Then we will add panic buttons in the case of manual activation. If the system is not working, then user can use the panic buttons to trigger the message for their emergency contacts. And then we will work on the user interface, which will be on our mobile application, which will allow the configuration, tracking, and interaction with the device. Is our block diagram. Here we are using Raspberry Pi, which will be the central processing unit of the system. Then GPS module provides the real-time location, and GSM for sending SMS alerts, gyroscope for detecting the motion and sudden movements, heart, heart and pulse rate sensor used to monitor the distress signals, panic button for the manual alerts, battery to supply the power, entire device, microphones and the camera are optional for recording the video and audio for the same intents or the good evidence. And then lastly, the mobile application user interface displays the alert and track status. As we can see in our diagram, we are having a mobile application which is under Raspberry Pi main connection, which is connected to the GPS module and gyroscope and GSM modules and panic button and many more. And it is connected to different sensors, and all of these are connected to the battery, which means we can see that all our circuit is mainly get powered through the battery. And it is the description of our blockchain diagram. Here, firstly, we can see data collections. The sensors like PPM, GPS, and accelerometer and pulse sensors continuously monitoring the environmental conditions and the user status. Then the data will be processed by the Raspberry Pi. The Raspberry Pi processes the sensor data. If a threshold value, example, sudden movements, abnormal heart rate is detected, it identifies a potential emergency. Then alert message or triggered message will be delivered. If an emergency is detected, the Raspberry Pi activates the GSM module to send an SMS and the alerts containing the user GPS locations to the emergency contacts. Then lastly, the user interface. The mobile application or the web interfaces receives the update allowing the contact to authorized to track the user location in the real time.